Put a light.
Yes, Kundan, is it audible now? Good evening, Dipesh. Good evening. Is it audible now? Yeah, Abhilash, good evening. Good evening. Yeah. Kundan's sound is not clear. So what is the issue? Is there some interruption, Kundan, or like what's happening? Okay, just wait a second. How's it now? Or maybe I'll just lower the mic a bit. How's it now? So interruption is like, is it breaking in between? Is it, Kundan? Little interruption is there. Okay, okay. So by interruption, I mean the voice is breaking, is it? I'll cross check.
Yeah. Ask how to understand. Topic, and it is a new topic added in the GATE syllabus in geography.
Yeah, so I've told the technical team about it. Till then, are you guys able to hear at least? The video is fine. The video quality is okay, and you are able to see the board properly. Regarding the sound, we are looking into the issue. Yeah. So Kundan and Rajan, can you please confirm like the video quality and the screen, whether the screen is visible or not? Yeah, Shan, it's like, yeah, try to cover the most important topics of compiler design. So it's a 3-hour session wherein we will discuss all the important questions which are expected in this coming GATE 2023, and I hope all of you know that all of you are clear that the GATE exam date has also been announced. Yeah.
Just camera. That
Okay. So yeah. So did I answer your question? That what we are going to do is we are going to see the most popular questions in compiler design, and we'll see questions on each of the various phases of the compiler, right? Okay. From scratch, would it be helpful as I have not learned CD before? Yes. Okay. So what I can do is okay. So when we are discussing compiler design, Shan, we will be covering almost all the topics. You will be able to understand, I hope. And if there is an issue, you can ask the doubts in between. You will be able to. I'll explain that part in detail if that is needed, right? Okay. So okay. So voice is slow. How is it now? Is it okay? Okay. So let's start with the session. Maybe I'll move the mic a bit up also, so that if there is any interruption, that is handled in a better way. Yeah. Okay. So, okay. I'll speak louder. That's fine. Perfect. So let's start with the session. And as you know that we'll be talking about, yeah.
So my dear student,
So we'll be talking about the compiler design in detail today, right? So let's see. Let's see. First of all, so we are starting with compiler designs, and we will see what are the most important topics that are there in the compiler design, and we will try to solve as many as questions possible on compiler design. Okay. So first of all, and I hope all of you attended the sessions on database management system, which was taken by Vijay Agarwal sir, and then engineering maths has been taken by Priyanka ma'am, and I took theory of computation on 24th and 25th. Now we are starting with compiler designs, and let's see what are the kind of questions that can come from compiler design. Let's start. So the first thing that we have in compiler design is what are the various phases of compiler, and let's see what are all the phases that exist in the compiler, and then we will see so weightage of each part, the weightage of each part that comes in the like that comes in the compiler, the various phases, and then we will see the weightage of each and every part that is there in the compiler, right? So Kundan says yes, lexical is there, syntax is there, semantics is there. Yes, Kundal, you are perfectly correct. And let me draw the brief diagram which will give the picture to everyone who might be attending for the first time also, right? So let's see how the various phases of compilers looks like. So first of all, the compiler has a phase for lexical analysis. And what is given to the lexical analyzer is the pure high level language. The pure high level language. Pure high level language is given to the lexical analysis, which will produce the tokens. So the lexical analysis phase will produce the tokens for us. And once we have the tokens, we give it to the syntax analysis phase. So what I am doing right now is to give you a brief overview what compiler is all about, and then I will tell what is the weightage of each and every phase of the compiler, and then we will see questions on each of the phases of the compiler, right? So this is roughly will be the format, and as Shiana asked, would the ones who have just joined would be able to who do not know compiler earlier, would they be able to understand? Yes, you will definitely be able to understand this. This will not be a issue, right? So let's see. So we have the next phase as syntax analysis phase. The next phase is syntax analysis. And in the syntax analysis, the grammar is also given. The grammar is also given. And this thereby you generate the parse tree or the syntax tree. Parse tree or the syntax tree. So right. So in the syntax analysis, you parse the given string and you check whether that string belongs to the grammar or not, belongs to the language or not, which will give you an idea, right? What give you an idea? Yes, definitely, Abhinash, you're correct. That's the grammar has to be in the context free grammar when you are giving in this scenario, right? The grammar has to be the context free grammar. You are correct, right? So now, once we have this, we go to the semantic analysis phase. We go to the semantic analysis phase. Semantic analysis phase. So what happens in semantic analysis? So what happens in lexical analysis? As we discussed, we just look at the tokens. The stream of tokens we get in this phase. So
you have to understand that
we get
graph, whereas
in the lexical analysis phase, right? So and in the syntax analysis phase, we get the parse tree, which tells us that if you are able to generate the parse tree, then you can say that the string belongs to the language, and if you are not able to generate the parse tree, then you can say that the string does not belong to the language, right? So this is one thing. Then we have the, in semantic analysis, what you are going to get is, you are going to get the semantically verified parse tree. So here you checked the syntax of the language, here you are checking the semantics of the language, that is semantically verified parse tree. That is semantically verified parse tree. This is what you get here. Semantically verified parse tree. Is it okay till this point? Yes, Shan, the team is looking into the issue, but I hope you are able to at least understand what I am trying to do, right? The team is looking into the issue, well, we'll just resolve it as soon as possible, right? So, is it okay till this point? We are able to get the semantically verified parse tree, which also checks the semantics of the language, right? So, next is, so what happens next is, once we have the semantically verified parse tree, I'll write it, maybe I'll add a new slide, and on that slide I'll tell you what happens in the next phase. So once we have the semantically verified parse tree, that is semantically verified parse tree, now this goes to the intermediate code generator. What is intermediate code generator? It generates the intermediate code generator. This generates the intermediate code, which is basically the intermediate code which is portable on which is machine independent, which is portable on all the you guys can guideline 3 address codes, the 3 address yes, the 3 address code is there, quadruples are there, triples are there, and then we have the indirect triples also. All of this comes in the 3 address code. So right, Rajan and Abhilash, you both are correct, right? Annotated parse tree is the one which we got in the semantically verified parse tree, is also known as the annotated parse tree. You are also correct and perfectly fine, right? Yeah. So now, once you have the so intermediate code generator generates the intermediate code, that is called IC, right? The intermediate code, I am not writing the full forms, I hope you know all of that. Now once the intermediate code generator is there, now what happens next is it goes to the code optimizer. The code optimizer, it optimizes the code. So there are various machine optimizations which are some of the optimizations are machine dependent optimization. Some of the optimizations are machine independent optimizations, right? So, right. And in this phase, we try to optimize the code. Like, for example, there are loop optimizations, there are peephole optimizations, there are, as we look at there is redundancy elimination, there is algebraic simplification, lot many things are there, which is all covered in the code optimization phase, right? Is to we optimize the code in a way that it runs more efficiently, right? So we get here the optimized code, and once we have the optimized code, this optimized code goes to the code generator, which will finally produce the assembly code. This is what the compiler is. There is nothing else which is left. These all the names of the compiler. Yes, there are certain things like, for example, so assembly code or the target code, we can call it anything. You all are correct while saying this. So we can also call it the target code, right? So if we see it again, this is the intermediate code, this is the optimized code, and so this is the intermediate code, this is the, okay, just a second, this is intermediate code and this is the optimized code, right? And we have the assembly, right? So then we finally have the assembly code, right? So hello. Now this will not go. So this is the IC, this is the optimized code, and this is the assembly code that we get, right? So all these phases of the compiler takes the help of the F handler. All the phases of compiler which handles the error. So for example, in any of the phases of the compiler, an error comes in. So which phase of the compiler is going to handle? So okay, yes. So okay. So we'll look. So again, Kundan, we are looking into the sound issue. Just wait for a while. We are just looking into it. Good. So so basically over here, if we see, this error handler is going to be connected with all the phases of the compiler, error handler, and similarly the symbol table manager is also going to be connected with all the phases of the compiler, the symbol table manager. Similarly, if you go back also in the previous phases also, they are also connected with symbol table manager and also the symbol table manager, and also to the syntax, and also to the symbol table manager, and then we have as I said, the error handler. Just a second. The error handler. So basically the error handler and your symbol table manager is something which is connected. Okay, Kundan, we are checking. Yes. So we are checking, Kundan. Just give us a moment. We are checking regarding that, right? So symbol table manager is not there, which is basically managing the various symbols, and error handler is there, which is also handling the errors. So right, so for example, all the symbols are stored in the symbol table, and the manager is going to tell us to hear which F, and they need information about the symbol, so symbol table manager is going to provide that information. And when we talk about error handler is something which is basically going to handle the error. So for example, in any of the phases of the compiler, an error comes up, and then in this way you'll be able to handle the error using the error handler, right? So this is roughly okay, Kundan, just give me a moment. I will cross check with it.
After we reach the ground, three cases in scale is, one is when the scale is absolutely, when the line of axis is perpendicular or from the mean level. The other one is when you are seeing from top of a building, or the third case is in case of uneven ground. You are clear with the case. Please read fully.
So okay guys, what we'll do is we'll take a short break of 5 minutes. We'll resolve the issue and then come back, right? Just give us 5 minutes. How is it now, guys? Is it audible now? Yeah. Is it better now? Can someone confirm? Kundan, can you please check? Is it okay now? Okay. So let's start. Or yeah. So others can also please come better than before, sir. Okay. Okay. So at least if my voice is completely clear, you are able to listen to me, then we can go ahead. If you are unable to listen to my voice also, then it is a big problem. Just let me know if that is the case. But otherwise, let's start. Okay. Now let's start with the next part. Okay. I'll be a bit louder then. It's clear. Okay, Abhilash. Thank you so much, Abhilash. Let's start now. Okay. So I think we all have discussed what are the various phases of the compiler, and we discussed that first of all we have the lexical analysis, then we are going to have the syntax analysis, then semantic analysis, then intermediate code generator, then we have the code optimizer, and then we are having the target code generation, and all of the phases of the compiler. We are connected with the symbol table manager, and they are also connected with the error handler, right? The symbol table manager is basically giving them the information about the symbols. The error handler is basically giving them the information about the various errors. If the error comes, the error handler is going to handle that, right? Perfectly fine. Shan, thank you so much. Right. So now let's go back and then let's see what is the weightage of each part in the GATE exam, and then we will, based upon that, we will do questions on each of these parts, right? So let's see the weightage. So for example, if we see the most important part, as I discussed also, the heart of the compiler is semantic analysis, is syntax analysis, and there that is also the heart of the questions which are asked in the GATE exam. So this is the part where the most of the questions are coming up, and we are generally having at least 1 to 2 questions from syntax analysis in every GATE exam, right? So that is basically the syntax analysis part, and the other parts of the compiler, yes, Shian will provide the notes also, that's not an issue. So once the session is over and the team compiles the things, you'll be able to get the notes. So syntax analysis is basically 1 to 2 questions we are having in general, and then we talk about semantics and all the remaining phases of the compilers, like basically the lexical analysis and all other phases that we discussed. They are having the weightage from 0 to 2 questions. So basically, in general, we are having 1 to 4 questions from compilers in the paper. Sorry, 1 to 2 questions are coming from the remaining phases, and 1 to 2 questions are coming from the symbol table, from the syntax analysis. So in general, the weightage, the number of questions that we are getting is 2 to 4. Let's see. Let me write down in a slide. Let me write down in a slide so that you understand it properly. The syntax analysis phase, as I said, is the most important phase, and you are going to get at least 1 question from there and a maximum of 2, and all the remaining phases you are going to get a minimum of 1 and a maximum of 2. So total of 2 to 4 questions are coming from compilers every year. So it's a small subject. It has so in general it takes less than 40 hours to complete this subject, and over here in this class, as I discussed, we will focus majorly on syntax analysis and also a few questions on the remaining phases also. That will give you a complete picture at how the questions are going to be asked. Yes, Kundan, you are correct when you are saying, so when we say syntax analysis, it has all the phases, all the parsers, LL1, LR0, SLR1, CLR1, LLR1, operator precedence parser, even the recursive descent parser, the predictive parser, all of this comes in the syntax analysis phase. So that's why I said 1 to 2 questions, and in general a maximum of total 4 questions that you get from the compilers, right? So this is briefly what the structure of the paper is. Now let's do questions as we did in the theory of computation also. Let's try to start solving questions, and in between I'll keep on helping you guys if you are unable to solve the questions, right? So let's see the first question for today. It asks the number of tokens in the below code snippet, and I'll set the timer for 2 minutes for you guys to solve this question. So you have some 2 minutes to solve this, and let's see who gives the answer in the first go. And this is basically a NAT based question, and the question is basically based on lexical analysis. Yeah. So Kundan, 80 is incorrect. Please cross check your answer. So I think all of the answers are incorrect. 80, 84, 80, 82, 81. All of you are incorrect. Kindly cross check your answer. I'll give you 30 more seconds and then I'll discuss the solution. Kindly cross check. Saurabh, you are also wrong. 81 is wrong. Kundan, you are wrong. Oh, Mansa is to 83. Even that is incorrect. Cross check. Cross check, Mansa. 82. So everybody is 80 plus. Just cross check.
What do you mean by relief dis?
Okay, so now let me discuss the solution. I think none of you reached the correct answer. Let me see where is the problem, and then let's try to see what is the correct answer, right? So anybody retried this question so that if they have any other answer, just type in the chat box. We'll see what is the correct answer now. So I have stopped the watch and I think it crossed the allocated time in gate, like that is just slightly less than 3 minutes. And let's see the correct solution now. So let's see. So the tokens are the ones which cannot be further divided, like the smallest entity, the smallest recognizable entity is called the token, right? So let's see over here we have integer, that is the first token. Main is 2, 3, 4. Till this 4 tokens, 5, 6, 7, 8, 6, 7, 8, 9, 10, 11 and 12. Till this 12 tokens, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Till this 24 tokens. Clear till now? Everybody is fine. Till this we have 24 question, 24 tokens. Thanks Pratik. Yeah. So till this we have 24, 79 Kundan. Just one more. Just a slight mistake Kundan. Yeah. Quite near to the answer Kundan. So somebody came below 80. I am happy. Okay. So we have 24 here, 25, 26. Now this entire thing, which is the string, goes as one token. The strings are characterized as one token. There's 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Till this 38, 39, 40, 41, 42. Till this we have 42 tokens. Everybody did have 42 tokens till this point. Can someone confirm till this 42 tokens? Is it okay? Kundan, did you have 42 tokens till this point? Okay, let's go further. Yes, 42. Now 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. 54 tokens till this point. And let me count these two tokens separately. This becomes 56. Now this part is left, which will finally decide the number of tokens. Right. Yes, yes. So we have 56 tokens from here. Okay. Yes, Shilpa, you also got 42. Good. So 56. Then we have 57 is this one, 58, 59. Now I think you might have done a mistake. Greater than equals to is one token. That's one operator. I think those who are getting 82, they are counting greater than equals to as two tokens. That's one token, right? Yeah. Thanks, Vijay. Thanks. Yeah. So 57, 58, 59, 60. This is 60. 57, 58, 59, 60, 61, 62, 63, 64, 65. I did not count it colon because that's one operator. This is a ternary operator. You might have counted this twice. Therefore, you guys reached to 82. You don't have to count this twice. Are you getting this point? The ternary operator is one operator. You do not count it twice, right? So I think the mistake was greater than equals to is one token. Ternary operator is one token. You don't have to count them twice. I think that is why you guys are reaching to 82, 81 or something like that, right? No, they are counted. They have to be counted once, Abhilash, because they are one. That is one token, right? The greater than semicolon is a ternary operator. That's one token, right? So as soon as the lexical analyzer finds greater than, it will search for a semicolon or for this. Let's call it colon, right? Okay. Yes, right, Abhilash. So 65, then we have 66, 67, 68, 69, 70, 71, 72, 73, colon is not to be counted, 74, 75, 76, 77. I missed one of them. Just let me cross check. Till this was 42. Till this we had 42. Let's cross check here. 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Till this is fine. 54, 55 and 56. Till this is 56. Right? Now 57, 57, 58, 59, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. 68, I did not count it this. 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79. Okay, I reached to 79. It comes out to be 79. Is it okay, guys? I think, Kundan, you were correct when you answered 79. Is it okay, guys? Yeah. Abhilash, is the solution clear? What about others? Abhilash was there, then who else was there? I don't remember the names. Kundan, you also got the same? Yes, this is one token. Yeah. So I think 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. Yeah. So I think 29 is the right answer. And you must have got it. Yes, Kundan. Good. Yes, Rajan. Perfectly fine. Yeah, Shian. So the tokens means all the identifiers and all the symbols which are unique entities which cannot be further divided. Right? Is it okay? Okay. So now let's move to the next question of the day.
The distance, capital H is the flying distance.
S attributed SDT is also known as dash STD. So it's a one-word question. I'll not give you time. I just want the answers from you guys. So it's an MCQ based question. So this is the question from which phase of the compiler? This is from the semantic analysis phase of the compiler. So SDT is also known as syntax directed translation. syntax directed translation. Yeah, thanks, Nikhil. Thanks. Okay. Kundan says B. Okay, Kundan will wait for the others' answers. Rajan says A. Kaushalya says BB. So, Kaushalya, there is no option called BB. It has to be either A or B, or there is nothing called BB here. So, Rajan says postfix. Anant says D. Okay. What about Abhilash? What do you think? What should be the answer? Okay. Just 30 more seconds to you guys to think upon. Abhilash says prefix. No, Abhilash, it's incorrect. Just 30 more seconds for you guys to think about the right answer. I don't know the answer. It may be D. Sir, S attribute is RHS. That's why postfix. Yes. So I think the answer is postfix notation. That is A. A is the answer. And I think only Rajan could do it correctly. Others were incorrect. Yes, Shilpa, you're also correct. Answer is D. The answer is not D. It's A. Sorry. Yeah. You are incorrect. I think only one answer. We could only get one correct answer. That is A. So answer is A. That is the postfix notation. So now let's try to understand it. Why it is A. So now I hope all of you know this part, that syntax directed translation
Placement.
the annotated parts. So syntax directed translation will give you the annotated parts tree. Translation will give you the annotated parts tree.
Sorry, decreased.
So what is syntax directed translation? It will give you the annotated parts tree, or it will also give you the semantically verified parts tree. And now we have various kinds of attributes. So I hope, just to explain this question, I'll have to give you a brief theory, and you all will be able to do it correctly next time, right? So when you say syntax directed translation, so basically the attributes may be synthesized attributes, or they may be inherited attributes. Let's see what are. So when we say synthesized attributes, there are two types of attributes. Either they are synthesized or they are inherited attributes. So when we say synthesized, that means, so what I'm doing currently is basically I'm doing the questions from all the remaining phases of the compiler first in the first 1 hour. So in the next 15-20 minutes, we'll finish all the phases of the compiler. Then in the next 2 hours, we will focus on the main the main heart of the compilers, which is the syntax trees, that is the parse trees or the syntax analysis, right? The next 2 hours we'll solve those questions. In the first 1 hour, we'll finish all other phases of the compiler, right? So let's see. Over here we were on the synthesized and we had inherited attributes. In synthesized attributes, the parents gets the value from the child. Parents gets value from child, and in inherited attributes, the child gets value from parent, or from its siblings. So this is briefly what inherited attributes
Cover or height of attributes
mean. So for example, if the production is of the type A goes to BC, if A is deriving the value from B and C, then it is a inherited attribute. If the production is of the type A goes to BC, if B is deriving that value from A or from C, then it is called a inherited attribute. Is it clear till this point, right? So this is called inherited and synthesized attributes. Now the question was regarding S attributes and L attributes. Now when we say S attributed definition or the L attributed definition, so once you understand this, you can understand the definitions of S attributed and L attributed. So when I say S attributed, it simply means that only synthesized attributes are allowed. So only synthesized attributes are allowed. Only synthesized are allowed. And when we say L attributed, it allows synthesized and left inherited guys. Synthesized, I think the spelling is wrong. Synthesized, where it is. So synthesized, and also it allows left inherited. So what do you mean by left inherited? Either you will inherit from your parent or from the left sibling, not from the right sibling. That is basically called an L attributed definitions basically, right? So now when we say S attributed, the semantic action will be written at the end of the transaction, end of the production. So when we say A goes to BC, let's say B multiplied by C, and say the semantic action is A dot val is equals to B dot val multiplied by C dot val. This is basically the semantic action which I have written for this. Now, in S attributed definitions, the semantic actions are written. Yes, Kundan, you are correct. Left sibling only and parents for L attributed. Perfectly fine. S attributed is bottom up while L is top down. You are perfectly right, Kundan. But now, the question is not about that. The question says that they are S attributed is also called as postfix. What does that mean? Basically, the semantic actions are written at the end of the production. Therefore, they are also called postfix. Therefore, they are also called postfix. Here, the semantic actions can be written anywhere. Like after this also you can write the semantic action, or you can write the semantic action after the production also, or before the production also. So therefore, before the starting the right hand side, right? So the semantic actions can be placed anywhere on the right hand side. Therefore, they are not having any such name. But in here, the semantic actions are being placed at the end of the transaction, end of the production. Therefore, we are calling them as postfix notations also. Like at the end, the post means at the end, right? So is it okay, guys? Could you understand the explanation? The question was very simple. It was basically an information based question, and I hope you can note down this information and it might be helpful in the coming GATE exam, right? Is everyone clear? Any doubts till this point, or just let me know. If everybody is clear, I can move ahead to the next question. So what about Saurav, Anant? Anant, we discussed this in the class. You should have done it correctly. Yes, Abhilash, it's fine, correct. What about others? Kundan, I think you gave it correctly. And Saurav and Anant, are you all okay with the solution? Yes. Okay. In the meanwhile, I'll give the next question. Okay. So this is basically again a NAT based question. So as the trend is basically for the NATs and the MSQs, I have purposefully kept more and more NAT and MSQ based questions. This might be helpful to you to see the kind of questions that might be there in the exam. So let's see. I'll set the timer again for 2 minutes. So this is again the question from semantic analysis phase. Yes, Anant, good.
Here, my dear students, centimeter cancel. So 4 upon 60, 60 into 1.5. So the height of the tower A is 90 meter. So my dear student, whenever you are clear in the concept, I hope you are clear. Is it clear, my dear students? Is this clear for everyone? Okay. See the students, if you are unable to remember the formula, if you know the similar triangles concept, just draw the diagram, and that can also be solved in 1 minute. Okay, I've just explained you each and every part. If I solve in a paper, it hardly takes not more than 1 minute. But when you are understanding the problem, you should know what is the mistakes you do. The length of the image is relief displacement. That is the conclusion point I want to tell you. And if you tell what is R1 is, it is the radial distance to the top of the object. Relief displacement increases with increase in height of the object, and relief displacement decreases with the flying height. If you can conclude in this way, the problem can be solved in very easily, my dear student. Now, another beautiful question in relief displacement, my dear student. Please see. A tall tower was photographed. A tall tower was photographed from an elevation of 700 meter above the datum. The radial distances to the top and bottom from principal points are 112.50 and 82.40 mm. If the bottom of the tower is at an elevation of 250 meter above the datum, then the height of the tower is. Now please take this question, my dear students. I'll be back in 30 seconds. Okay.
Yeah, sorry guys for the interruption. Sorry guys for the interruption. Actually, there was some issue with the sound. Therefore, it took some time for the technical team to resolve the issue. Yeah. Is it okay? Okay. Yeah. Is it okay now? Can somebody confirm the audio and video? I'll again start now. Yeah. Thanks, Abhilash. Sorry. I'm really sorry for the delay. Actually, the technical team came over and they tried to resolve the issue, and I hope it is resolved now for forever. Right. Now let's see. So what was the answer from you guys? Anand says 4929, Abhilash says 4929, Tejashri also says 4929. Sound is clear, but it's not very clear. So, okay, I'll move the mouse a bit up. Yeah. Is it audible now? Yeah. Okay. So now let us see how the answer is 4929, and the answer is correct. You guys are correct when you stated the answer is 4929 only. Right. Let's see how the answer is 4929. Okay. Okay. So let's see the answer. It is 4929. Let me draw the syntax tree for the same. So the grammar is this. Okay. So this is the grammar that we have. Cut. And then we'll paste it. So this is the grammar that we have. So right. So now the string given was xxy xxz. Am I correct? Is it the string? Let's check. xxy xxz, perfectly fine. So now let us draw the syntax tree for the same. It is xxx. Now you want a y, so you will replace it with a ys. Now you want a xxs, and now you want a z, right? And if you see the parse tree, this is basically xxy xxz. The yield of the parse tree is basically the output of the parse tree, and it produces the strings which we want, right? Is it okay, guys? So this is basically till this point. Is it clear? So you got xxyz, xxy, xxz, right? And now let us see what is the output, right? So now we know that 9 is printed. So again, this is basically an synthesized definition, which means you have to calculate the prints the last occurrence of the variable, right? So let's see how the prints are going to happen. You go like this. This is the first occurrence of s. Over here, this is also the first occurrence. When you come here, you will get the last occurrence, so which is 4. So from sz, you will have a printing of 4, right? So there you again move. xxs gives you print of 9. So for the last occurrence of the parent, you will print the value. Is it okay? So now this is 9. Over here you get a y. Y is so x goes to ys, print gives a print of 2, and similarly xxs will give you a print of 9. So you get, so this is printed like this, 4 9 2 9. This is what you are going to get. So 4 will be printed first, then 9, then 2, and then 9, which is the answer to this question, right? So now those who do not know how the syntax tree, I think this should be known to everyone, that how you are going to make trees. Now during the evaluation, if it is a synthesized attribute, what you are going to do, you are going to do the semantic action when you are seeing the parent for the last time from while traversing the parse tree top to bottom, left to right. So you are going to you are going to traverse the parse tree top to bottom, left to right, top to bottom, left to right, and on the last occurrence of the variable, you are going to last occurrence of the parent you are going to print. Is it okay till this point, everyone? Yes. Yeah. So Abhilash, Kundan and Anant, all of you got the answer from the same way. Tejashri, can you just confirm me? Do you got the answer in the same way? Yeah. Guys, can you please confirm so that I move ahead to the next question? Okay. Rajan says CC. Yes, it is crystal clear. I hope it is not all clear. It's clear. Yeah. Okay. All good. So Anant says yes. Now let's move ahead. And this is the question from the optimization phase of the compiler. Oh, and it is basically a MSQ based question. Pardon me for the typo. It is an optimization phase of the compiler. Right. So I'll give you some 2 minutes to solve this. Let's see. Just give me a second, guys. I'll set the timer. It is set to, yeah. Okay. See, he says CC means crystal clear. Okay, Kundan. Good. So in emails we say CC carbon copy. So I got confused. Okay. A, B, C, D. B should not be the answer. A, B, C, D should not be the answer. Anand says B, just B, Anand. It's an MSQ based question, as I said. Just cross check. Kundan says A, B. Let me check. No, Kundan, you are incorrect. Just cross check. You say BC. So Rajan says BC. Okay. It's still incorrect, Rajan. Anand says BCD. Yes, Anand, you are correct. What about others? Just cross check and then I'll answer it in another 30 seconds. Yeah. Okay. So Kundan says getting confused because of the terms. Okay. Let me check. Let me check. I'll explain to you the terms. Not an issue. Anant, your answer is correct. Kundan, yours is incorrect. Rajan, yours is also incorrect. What about Ablash? What is your answer? Adish says BD. Adish, you are also incorrect. Let me correct. Let me tell you the right answer. So Kundan, can you confirm the voice is now okay? Yes. Good evening, Aman. Yeah. Voice is perfectly fine now. I think there is no interference. I hope there is no interference now. Right? Yeah. So okay, let's see the question. It says so the code snippet is basically using a loop, and it says that A is being plussed to B plus 30, and you are printing Amit Goyal, right? So now this is basically the question loop. What are the various optimization which are being done on the loop, right? Okay, so it says 70% clear. Okay, let's we'll try to make it 100% when I give you the next question, right? But otherwise you are able to understand properly. Is it okay, Kundan? You are able to understand properly? Yeah. So over here we have A goes to B plus 30. Now this part. So now what is loop jamming? Now let me explain what are these terms, and then I'll explain the answer to this question. So first of all, loop jamming, it means you are merging two loops. This is like merging two loops. Here we have only one loop, merging two loops, two or more loops. So here we have only one loop, so therefore loop jamming goes out of the picture. Now loop unrolling might help over here. For example, instead of printing Amit Goyal, so this n may be say initialized somewhere to 100. Now if you print Amit Goyal 100 times, you can simply write it as, keep it out of the loop and put the printf statements 100 times. So this way you can unroll the loop, or what you can also do is, in the same loop you write it twice, so thereby the iterations of the loop will be reduced to 100 by 2, which is 50. So this is called as loop unrolling. So loop unrolling can happen over here. Is it okay? Is it okay? And now what else we have? The code motion and frequency reduction, it is basically, that is also correct. That is because of this statement. Now why I am saying so that the code motion and frequency reduction can happen here? See guys, this is A goes to B plus 30. Now this statement nothing to do with the iteration of the loop. Even if you are going to do it 100 times, the answer will remain the same. That is, A is going to get the value. A is going to get the value. B plus 300, that is 200 plus 300, which is 500. And now this has nothing to do with the loop. So therefore I can move it out of the loop. That is called code motion. I can move the code out of the loop, therefore it is code motion, or I am reducing the frequency. That is also a synonym for the same. I am reducing the frequency of the A goes to B plus 30 from 100 to 0. So therefore all these three are the answers, that is loop unrolling, code motion and frequency reduction. Is the solution clear now? Kundan says you are getting confused because of the terms. Is it okay? Are you clear with the terms now, Kundan? Yes, loop invariant is also code motion. So something which does not vary with the loop, that is also code motion. So if an option called loop invariant also, that would also have been correct, because what is invariant, Kundan? Basically it is something does not affect the code, does not the loop does not affect if something is not affected by the loop, therefore that is called as loop invariant. Is it okay, Kundan? Yeah. Loop fusion and loop jamming are the two synonyms. Loop jamming and loop are synonyms. Loop jamming and loop fusion, all of them are synonyms. Now let's move ahead. A second. Loop unrolling is also possible. There should be B, C and D. Right? Is it okay, guys? So Rajan, which part do you want me to repeat? The last part, is it? Rajan, can you just precisely tell me which part needs to be repeated? I'll repeat that part. loop unrolling is, yes, loop unrolling is possible. So unrolling means basically you are trying to unroll the loop. So right now the loop is say running for n. I assumed n is 100. The loop is running n times. If I write this statement twice in the loop, printf Amit Goyal, if I write twice, then the loop is being run by n by 2 times the loop, right? So which the thing which was running 100 times, now it is running 50 times. And in the best case, what I can do is, I can simply write printf statements n times. That way you are completely unroll the loop. That's the best case, right? So that unrolling can happen over here, that therefore that is also the part of the answer. Is it okay now, Rajan? Rajan, is it okay now? The loop unrolling? Yeah, you have to precisely tell me the doubt, Rajan. As far as I understood, loop unrolling was unclear. I have explained it in detail again. Okay, guys. If there is anything else, please comment in the comments, Rajan, so that in the chat, so that I get to know if something is still unclear, right? And code motion, frequency reduction, and loop invariant, all of them are same. That means moving the code out of the loop, which is independent of the loop. A goes to B plus 30 is basically you are adding again and again, you will get the same answer. Frequency reduction is strength reduction. Okay. Again, strength reduction is a generic term that you will use. For example, if the operation says A is equals to A multiplied by 2, that is same as A goes to A is shifted is left shifted twice, left shifted by 1. A is left shifted by 1. So basically, A is left shifted by 1. You can write it out as less. That is called strength reduction, right? So that's a different term. Loop invariant and frequency reduction, and as I said, this code motion, they are all similar terms, right, Kundan? Okay, now let's move to the next question. And this so basically questions on the lexical analysis. We did questions on lexical analysis. We did questions on semantic analysis. Then we did questions on code optimization. Now let us move to the most important phase of the compiler, which I discussed, is syntax analysis. And now we'll do, for the next 1 hour 45 minutes or 2 hours, we will discuss syntax analysis only, because that's the most important phase of the compiler, right? When it comes to syntax analysis, let's see the most simplest question that we have on syntax analysis. I'll just in the beginning I'll set up a simpler question. Let's see the simpler question first. So again, guys, as I say, from these 4 phases of the compiler today, and we have covered these 2 phases. This phase we am covering now, which is the longest phase of the discussion, right? Now, when you talk about Tejashri, the answer is B. For which question, Tejashri? Yeah, just let me know for which question the answer is B. Now, what are the remaining phases? One phase is intermediate code generation and the target code generation. And target code generation. So again, on target code generation, we do not have many questions in GATE, as it is like generating the final code, the assembly code, right? And intermediate code generation, basically we have very simple questions on GATE based on intermediate code generation, which we generally discuss in the class, and just based on that theory you can solve. There is nothing much tricky about these 2 phases. Now the most of the trick lies in the syntax analysis phase, which we are discussing in detail now, and we will do some 10 to 15 questions on syntax directed translation, syntax analysis, so that all of you have good confidence in the exam while appearing for the exam, right? So now let's move to the syntax analysis phase, which is the most important phase, as I said, right? So let's set up the timer again. You should be able to answer it within 1 minute. So again, it's an I would say this is again an MSQ based question, not MCQ. I have set it up as MSQ based question. Take it as an MSQ based question. So Tejashri, it's an MSQ based question. Abhilash, it's again an MSQ based question. Just cross check your answers. So Hemashri says BD, Tejashri says BD, Anand says BD, Abhilash, any corrections to the answer? Abhilash also says BD, Adish also says BD. All of you are 100% correct. The answer is B and D. It is a bottom-up parser and it is also a shift-reduced parser. Answer is B and D. Now, when we move to the syntax analysis, let me briefly tell you that how are we, yes, Rajan, earlier you were incorrect. The answer is B and D. It's not a top-down parser, it's a bottom-up parser. Let me briefly define the classification of the parser so that everybody is on the same page. I'll briefly take 1 minute to find the parsers, the classification of the parsers. Answer is BD. All of you are correct. Let me briefly define what is the classification of the parsers, and then we will move ahead, right? So now here goes classification of the parsers. So the parsers are categorized into two parts. One is the top-down parser and other is the bottom-up parser, which is called BUP. Top-down parsers are also called as TDP parsers, right? And in top-down parser, first one is brute force approach, which has an exponential complexity. Then we have LL1 parser. Sorry, before that, so LL1 is also there, but let me go step by step. This is top-down, this is a brute force. Then we have recursive descent parser. Recursive descent parser. Then we have LL1 parser, which is a predictive parser, which is also called as recursive, non-recursive descent parser. So all of these are the same names and they might confuse you with these names. So they might ask you, is this grammar, given grammar is a predictive grammar? So you have to check whether the grammar is LL1 or not. So therefore, so Aman says screen is not clear. I think Aman, what you need to do is you need to refresh your browser once. I think screen should not be an issue. So yes, LL1 is non-recursive and also then you are correct while saying. And when we talk about bottom-up parsers, we have first of all we have the operator precedence parser, which was the question right now. And all these bottom-up parsers are also called as SR parsers. That means shift and reduce. Shift means pushing and R means reduce means popping also, right? So now in operator precedence parser, when we see, okay, and we also have LR0 parser, SLR1 parser, CLR1 parser, and also LLR1 parser. And all these parsers, these four parsers, four of them, they are also called as LR parsers. So I hope this brief summary will help you in solving the question that I just gave. Is it okay? Right. Yeah. Okay, Kundan. When we take a break, when I give you the question, I will try to resolve it and try to make the sound as 100% clear. Right. So right now, let us keep proceeding, and I'll try to make it 100% clear when I give you the next question. Right. So till this point, everything is clear. Guys, can you please confirm? All good till this point? Okay. Yeah. So yes. Okay. So Adish, Rajan, Abhilash, everything clear till this point? Yes. Okay. And again, thank you, Kundan. Let's move ahead. So now what is the structure of a parser when we have, okay, Abhilash, thank you Abhilash, thank you for confirming. So now what is generally the structure of parser is, in general when we have a parser, I'll just give you a 1 minute theory again, and after that we will be only solving question. Now, what is the job of a parser? Parser basically parses your string and tells whether your string belongs to the language or not, and is one which is being represented by the grammar. So the parser will get the grammar from the beginning and it will be able to parse the grammar and parse the string and tell you clearly that whether the string belongs to the language or not, right? So now let us see how does a parser works. In general, a parser will have an input buffer. In the input buffer, what will be there in the parser? What will be there? The input string will lie in the input buffer, right? Input string will lie over here. Input string will lie over here, and what will be there in the input string? That it will be ended by $. So for example, if I want to generate a plus b plus c, it will be written like this in the input string. Is it okay? Is it okay, guys? Right? Now there will be also a stack in every parser. You will find a stack also. So what is a stack? In basically, stack will give you the memory component. If you need to memorize, you need to store the intermediate parse tree. Basically, this stack gives you that capability. Therefore, every parser will have a stack with itself, right? Now, once you have a stack, then you will have a parsing table. Every parser will have its own parsing table, which will tell you the semantic actions, which will tell you the syntactic actions which not needs to be while parsing the string, what needs to be done and what need not be done. Everything will be told by the parsing table. So what you can say is, parsing table is basically the brain. It is basically the brain of the parsing algorithm. Any parser, if you take, the brain is basically the parsing table. It tells the various actions that are there, right? And then finally you will have a parsing algorithm. This is basically the parsing algorithm. This is basically the parsing algorithm. What parsing algorithm does is, it looks at the stack top, it looks at the input buffer, right? It looks at the input buffer and then consults the parsing table to take appropriate action. So this is basically the overall view of the, this is in general basically the overall view of the parser, right? This is how the parser works. This is how every parser that we are going to discuss is basically be doing this in one way or the other. So when we said that we have various parsers like operator precedence parser, LR0 parser, SLR1 parser, LLR1 parser, CLR1 parser, and even the LL1 parser, all of them will have the same structure, but their method of making the parsing tables, which is the brain, will be different, and they will have a different parsing algorithm. Although all the LR parsers will have the same algorithm, but the parsing table of all of them will be different. This is basically the brain of the parsing method, right? Is it okay till this point? So now let us do like some 10 to 15 questions on, at least 10 questions on basically the parsing, right? Let's see. So should we move ahead? Okay. Yeah. So here is your first question for you guys. This is a NAT based question. So let me set the time, and you have some 2 minutes to solve this. Okay. So, okay, Hemashri came back down to 5. No. Just cross check once. Almost all of the answers are like one of the answers is correct out of all the things that I can see. I just give you 30 more seconds to give me the final answer. So Tejashi says 8, Abhilash says 7. Tejashi, just cross check your answer once. It's not 8. It's not 8. Yes, your definition is correct, Kundan. You are correct in your definition. Hemashri came to 6. 10th not possible in CFG. Yes, you are correct, Anant. So what is the final answer? Tell me the final answer. So I've given you some 10 productions. Which of these are allowed in the operator grammar? Oh, Anand came back to 6. I think the answer is. Let me cross check. Yes. So the answer is 6 only. Yes. Kundan has come back to 6. Anant has also come. Rajan, I think still there is a mistake. It is 6. Answer is 6. Let's see. Now let us see the solution. So now when we say about operator grammar, only two kinds of productions are not allowed. 3, 8, 10 not allowed. 3, 6, 8, 10 not allowed. Yes, Abhilash, you are perfectly correct. Now let us see. Let me explain it for everyone now. So now when we have how many of the following productions are not allowed in the operator grammar, so we should know what is an operator grammar, what are the productions which are allowed by the operator grammar allows. Does not allow two kinds of productions. What are those two kinds of productions? One is A goes to epsilon, that is null productions are not allowed. Null productions are not allowed. And the second thing which is not allowed is A goes to BC, that is no two non-terminals should come together. No two non-terminals should come together, right? So that is basically the definition of an operator grammar, which you should know. This is basically a factual information, and if you know this factual information, you can simply solve this question. Yeah, okay. So so now you see A goes to B, this is perfectly fine. A goes to A, this is perfectly fine. A goes to epsilon, this is a null production which is not allowed. The count goes to 1 here. A goes to BC, this is perfectly fine. A goes to AB, this is perfectly fine. A goes to BC or A goes to AB, this is no two non-terminals should come together. So this does not follow this. Rule 2 is violated. Violates rule 2. So therefore this is now ABC is perfectly fine. ABC again, this is again violating rule 2. Perfectly fine. Is not even context free grammar. How we can talk about right. So how we can talk about operator grammar. So I kept it purposefully to check whether you guys still remember that we are talking about context-free grammars when we are doing the syntax analysis phase. Kundan, you are correct for option 10. It is a type 1 grammar. Is it allowed for operator grammar? It's not allowed. Therefore, I am saying this is also not the answer. So this is not even a context-free grammar. The context-free grammar does not allow this. So therefore, we'll have it as the fourth option. So how many productions are allowed? 10 minus 4, which is nothing but 6. So 6 is the right answer. I hope you get the right. Okay, guys. Right. Yeah. Kundan, you got my point. Yes. Yes. Now people are clear. Kaushalya is also clear. Now let's move ahead with the next question that we have for you. So this is again an MSQ based question, and this is basically again, as I said, syntax analysis, and it is based on operator grammar. And I hope I'll give you another 2 minutes to solve this question. And yeah. So guys, what are the answers? Abhilash says AD, Kundan says AD, and Anant also says AD. So if many guys are saying answer should be AD, let's see whether we have AD as the answer or not. So what about others? Abhilash has answered, Kundan has answered, and Anant has answered. What about Kaushalya and Hemashri? What are your answers? Hemashri also says AD. Good. Any other answers, guys? So Abhilash earlier said ABD, then he came back to AD. Kundan, you are giving the answer completely. Acha, so you said initially said you BD and then you are coming back to AD. Okay, good. Rajan says ACD. No, Rajan, just cross check. Adish, you are also saying AD. Good. So let us see. Let us see what is the answer. I'll stop the timer now and I'll remove it. So the answer is AD, guys. Right? So now let's see AD. So Rajan has again also come back to AD. So now how to solve such type of questions? The question is basically on the operator grammar and talking about the operator precedence table of the operator precedence parser, which is basically, as I discussed, is basically the brain of the operator precedence parser, right? So let us see how we are going to solve such kind of questions. So how to make the operator grammar? Let's see, we'll take this grammar and we will see the parsing table, complete parsing table we'll make, and then we will solve this question so that everybody is on the same page, right? Now let's see. Let me bring back the grammar from the previous page so that we can make the parsing table properly. What do I want? I want a screenshot. Just give me a second. Paste. So this is, here we have the grammar, and let us make the table for this. Let us make the parsing table for this grammar. So when we are taking operator parsing table, when we are making, what we are going to do is we will have the terminals. All the terminals will be on the left hand side also, and on the in the rows also, and in the column also. What are the basically the terminals here? Plus is there, multiply is there, ID is there, right? What do we have? No, Kundan, we'll have just one session on this, on compilers. So we have plus, multiply, ID and dollar as the terminals, plus, multiply, ID and dollar as the terminal. So dollar is basically to represent that the string has ended, right? Okay. So now in this parsing table, what we are going to do is we are going to write the precedence of each operation with respect to the other operation, right? This is how we construct the parsing table, and this is how we construct the parsing table. Just a second. So this is how we'll construct the parsing table, and let's see what is the parsing table for this. So in general, always remember that dollar has always the least precedence. So if it has the least precedence, we'll write it as this. And if dollar on dollar is basically the except, and basically over here dollar has the least precedence, so it will be like this. So what does the dot in between signify? So for example, if some of the language has greater than or less than in itself, then in that case, to differentiate that, we put a dot over here. If you don't put it, it's fine. But if the grammar has greater than or less than, then in that case you will have to put a greater than and less than symbol, a dot between the greater than and less than symbol, right? Now for ID, in general, ID has the highest priority, therefore we can simply fill it as, so ID on ID is a problem, which is a syntax error, and this ID has higher precedence, so therefore we'll write it as this. So till this point, is it clear? Now our operators, plus is basically, now this grammar we can see clearly, it is a left recursive grammar, so therefore left hand side plus has higher precedence. So basically this is basically the left side, or basically the stack side, and this is basically the right side, or basically the input buffer, right? So now multiply has, in general, the plus is basically left associative, so therefore the left side plus has higher precedence. Similarly, the multiply, we are seeing it as left associative, so therefore multiply also has, since it is left recursive, therefore multiply will also have left associativity, right? Now in multiply and plus, multiplication is farther from the start symbol, therefore it has higher precedence. Then it has higher precedence than plus. So therefore among multiply and plus precedence, and in multiply and multiply again plus and multiply has the higher precedence. So this is how we can make the parsing table for the operator precedence parser, right? Now let us see the options that we have. So we can say PT of plus plus, the left, so since plus is left associative, as we saw, therefore it has higher precedence. This is correct. A is correct. A is the part of the answer. Multiply, as we know, it is left associative. This is incorrect. This is saying it is right associative. Now, PT of plus and multiply, again multiply has higher precedence. We can clearly see in the table also that we made, PT of plus comma multiply, and it has to be multiply has higher precedence. So if you see this, you can see plus in plus and multiply, this is also incorrect. Now in multiply and plus, again plus, multiply has higher precedence, therefore this is correct. So A and D are correct options, which is the answer to this question. Is it okay, guys? Right. Yeah. So I hope all of you did in the same way. Again, you don't need to make the entire table for solving this question. You can solve it without making the table also. I just explained it in a proper way so that those who have forgotten it, it should be brushed up for them, and those who do not know, they also learn together, right? But in general, you can simply see that and tell what is the precedence of the operators and what is the associative of the operators based on the precedence and associativity. You can simply answer it. You do not need to look at the parsing table also, right? So because you can clearly see in plus is going to be left associative, multiply is going to be left associative, and multiply has higher precedence because it is farther. But just based on this information, you will be able to solve the question. Is it okay, guys? Yeah. Should we move ahead? Can somebody confirm? Is it okay or not? Sir, if we replace the plus by multiply, which so over here, if you replace plus by multiply, so why? Because if you need just multiply, then it is fine. But why would you replace a plus with a multiply? You either you will remove this, and then only you will have E goes to E cross T. But why would you have two multiplies? That does not make sense, Rajan. Right? So now let's move to the next slide. And this is the last question which we will do on the operator grammar. And here is the question for you. I'll give you again 2 minutes to solve this. It is an MS question. It is basically based on operator grammar. So Pranav Maheshwari asked, sir, for how many marks compiler can come in exam? Again, Pranav, as I said, there might be 2 to 5 questions, 2 to 4 questions. So the weightage at max, it can go to 5 to 6 marks. Yeah, at max. So since it's a small subject, it takes generally 40 hours to me to complete the subject. So it's a smaller subject. Therefore, the weightage is something like that. Yeah. So some of the answers are A, B, D, and A, C, D. Okay, none of the answer matches. Guys, please concur on one solution. I'll give you 30 more seconds and then I'll explain. So yes, yes, Kundan, it's basically MSQ based question. Uh, so yeah, Kundan says A, Aman says A, Mansa says CD, Harish says BD. All the answers are like completely different. Adish says D, Mansa says C, Rajan says CD. Oh, what about Abhilash? What is your answer? So let me stop the clock. So the answer is, so I want to derive the string A plus B. So let me read out the question for you guys. Consider the following operator grammar. The grammar is the same which I gave earlier. Now the operator precedence parser stack starts with a dollar. So you have a dollar at the bottom of the stack. Which of the following is a possible stack configuration during the derivation of the string A plus B? So you want to derive the string A plus B from the given grammar. The bottom of the stack up to the left hand side. So basically when I'm writing $A, it means dollar then A, $B means $B, dollar plus means dollar plus, and dollar plus B means dollar plus and B. This is how the stack looks like. So it is asking you whether any of these configurations is reachable when you are making the path tree for the same. So Adish says BD. Okay, let's see Adish, what is the answer? Let us try to do it together to see what should be the right answer. So for this, what you need is the parsing table and of course the knowledge of the parsing algorithm, right? So the answer is A, C, and D. Answer is A, C, and D. So that means this is correct, this is correct, this is correct, this is incorrect. ACD is the right answer. Rajan, you are perfectly fine. And your answer is perfectly fine, I mean. So Adish, what is the issue? Why did you got B? Mansa, you got CD. Where is A? And Kundan also says A. So let's see how we reach to the right answer, right? So now let us see the parsing. So here we need the knowledge of the operator grammar. So but before I move ahead, now let me clearly tell you what kind of question can be asked from the from the parsers. Any parser you take, 3 kinds of questions can be simply formed. 3 to 4 kinds of questions can come. One is a factual question on the theory of the parser. Another question can be basically based on the configuration of the stack. One more question can be on the parsing table. Or so basically this is basically a question on algo, parsing algo. This is the question on parsing table, or whether the grammar is of a particular type or not. Like whether it is LL1 or not, LR0 or not, LL1 or not, SLR0 or not, LALR1 or not, CLR1 or not, and so on and so forth. So these are only the 4 kinds of questions that can come up on any parser. I'll try to cover maximum of them. So like this, we did question on we did it on operator grammar, operator precedence grammar. We did a question on grammar type. We saw are allowed by the operator grammar or not. Then we discussed the question on parsing table. We made the parsing table also. Then we are discussing the question on configuration. So we'll try them. And since we took around 10-minute break also in between, I'll extend the session till 9:15, and I'll try to cover at least 2 to 3 parsers in detail. The remaining parsers, similar questions will be asked, and you know the theory, and I hope you will be able to handle all of them. Right? I'll try to cover at least 3 parsers. This is the first one which is going on, and then we'll cover the LL1 parser, and we will also cover LR0 parser 2. I'll try to cover all 3 of them at least, and on the remaining parsers also you will have similar types of questions. But if we have time, if we increase the speed in between, we'll be able to also cover other parsers too. But this is basically to make you guys understand that this is the crux. The questions will be on all these three to 4 things. Nothing else can come when we talk about compilers. And the idea of this session is to give you a flavor that how the questions will be asked in GATE exam, and how what are the various varieties of the questions that you can get in the GATE exam, right? I hope it is clear till this point. Can somebody confirm so that I start solving this question? Yeah. So guys, can you please confirm? Rajan, Kushalya, Adish, is it okay? You got the idea that how the questions can be, variations can come in the questions? Yes. So Kundan, yes. Okay. So now let's see this question. We know, so we have the operator precedence table in our minds, and we know this grammar. And now let us see the string plus B. So the string that we have is A plus B dollar. Dollar is basically following the string. And the contents of the stack are initially just dollar, right? The contents are this, yes, 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 okay, perfectly fine, guys. So now let's see if the stack actually has dollar. We read a dollar, so the top of the stack is dollar, and now we have an A. So that is A is an ID. We know that ID has higher precedence than dollar. So therefore, if the precedence is higher or less than, so if the precedence is greater than equal to, in that case, we push the contents in the stack. So we get the new contents of the stack will be dollar A, and sorry, so it will be dollar A. Now the input pointer moves to this point. The input pointer is there, and the stack top is A now. One of the options was dollar A, so that option is correct. So the option dollar A, this option is correct. We are getting this, right? Is it okay, guys? Yeah. Okay. So now next is we have A and then a plus. We have an A and a plus. We know that ID has higher precedence, right? We all know this point, that ID has higher precedence. If you do not know, you go back to the answer, the parsing table that we made, you will find that ID has higher precedence. Now, if the stack top has higher precedence, then we are going to do what we are going to do. We are going to pop, and when we pop, again the stack configurations become dollar, and we move, and we will remain at plus only, and we will do the corresponding reduction to make the parse tree also. So the parse tree, so the only reduction for A, which is ID, possible is ID goes to T, because the grammar given is E goes to E plus T cross slash T, T goes to T cross F, and F goes to ID, right? So we have reduced it. Yes, Kundan, you are correct. Now we have dollar and plus. We know plus has higher precedence, therefore plus moves inside. So the pointer will now move here and plus is lying over here. Okay guys, till this point, right? So when the operator on the top of the stack has higher precedence than the input buffer, then in that case you are going to pop and you are not going to move the input pointer. But when the operator on the top of the stack has lesser precedence or equal precedence than the input buffer, in that case you are going to push, and in that case you are also going to move the input pointer. I counted non-terminal in this case, answer will be ACD. Yes, yeah. So now over here you have dollar and you have plus. Now plus is being compared with B, which is ID has high precedence. So now one of the options was dollar plus. As far as I remember, yes, so dollar plus is an option. You also get dollar plus. So AC is also the answer. Now B has higher precedence. The plus, in this case, you are going to move B at the top of the stack. The stack pointer comes here, and you will move the input pointer also to dollar now. So this is currently the configuration of the stack, and this is currently the configuration of the this is currently the input pointer, and this is currently the configuration of the stack. Just a second. Just let me remove this. Right? Clear till this point? And dollar plus B is also in the option. So this option is also correct. This option is also correct. Sorry. Right? Is it okay? All these options are correct. We never got dollar B. Now let's see whether we get it or not. Now, when you compare B with the dollar, you know that B has higher precedence. You are going to pop out B. You will not increase the input pointer. In this case, B, which is an ID, will be reduced to T. So you want an ID plus ID situation, that is A plus B situation. So therefore, I am just deriving. It's a bottom-up parser. So if it's a bottom-up parser, you will start from the bottom. That is the string, and you will reach the initial symbol, which is E. Right? If you can do that, then you can say that the string is parsable by the parser. Right? So now B has been popped out. So the current configuration of the stack is this. So the current configuration of the stack is this. Now plus is being compared with dollar. We know that plus has higher precedence than dollar because dollar has the least precedence. In this case, again, you are going to pop out and you are going to do the corresponding reduction. Finally, dollar will be matched with dollar, and then you are going to accept it. So this configuration that is dollar B is never reached. Therefore, this is incorrect. So the answer is going to be A, C, and D. That's it. Right? And how the reductions will happen in the tree? So over here, so at the end you want to reduce plus. The plus requires E goes to E plus T. So you are going to do certain reductions over here. You are going to make this T as E. Now this is T, this is plus, and then you are going to connect all of them to make an E. So you got an E, therefore this string is parsable by the parser. Right? Is it okay, guys? All good? So did we understood the solution? Adish, now correct? Answer is correct now? You corrected wrongly, I think, as far as I remember. Rajan also said ACD, that's fine. I hope all of you now understand the answer, right? Okay, good. So now let's move to the next parser that we have, that is LL1 parser. We'll do some 3 questions on LL1 parser. Again, one question will be based on asking that whether the grammar is LL1 or not. One of the other varieties is whether this configuration is reachable or not, or other question can also be on, and another question can also be on whether the contents of the parsing table, that can also be one of the questions. So right, so we'll do 3 questions on LL1 grammar, and then we will move to LR0 grammar. Right, so let's see LR0 parser. Let's see the questions on LL1 grammar. So let's move forward. So here is the question for you guys. Consider the following grammars. Which of the following is LL1? And this is an MCQ based question. You have 2 grammars with you. And let me set the timer for you guys. You should be able to solve this within 2 minutes. It's quite easy question. Okay, Adish says it's clear now. Rajan says clear. Okay, Anant also says clear. Good, good guys. Now solve this question. Yeah. So Adish says, is the production is the sir S in the first production of S is capital? Yes, yes, it should be capital. Let me make it capital. It should be capital, right? It should be capital. So so it is A, S, and A. Thanks, Adish, for correcting. Yeah. Few answers. Adish says C, Anand says C, Kundan says C, and Rajan also says C. So then answer should be C only. Both C1 and G2 no, not be C. So you guys think that both of them are LL1 grammars? Just cross check once. I have changed also this S to ASA and epsilon. A goes to C epsilon. S goes to AA, B, B, and A goes to C epsilon, and B goes to D epsilon. Just check once. Just check once. Answer should not be C as far as I remember. Just let me, yeah. So Kundan also thinks C. Okay. Okay. So now Adish says B. Rajan says B. Okay. Mansa says B. Good. So yes, the answer is B. The answer is B. Now let's see how it is. So here we can clearly see this grammar first. Over here, the conflict can be in the S row of the table. We need to check that the first of this guy, which is A, has no intersection with the follow of S. Follow of S. Now follow of S is what? So S goes to ASA. Now follow of S is basically, so the production given to us is S goes to ASA. S goes to, just let me check, S goes to ASA is given to us, right? Now, and A also goes to C, right? We want to calculate the follow of S. Now follow of S is nothing but first of A. Follow of S is nothing but first of A. First of A is nothing but C comma epsilon. But epsilon does not come in the follow. Epsilon does not come into the follow. Therefore, follow of S is equals to follow of S, which is also known. There is nothing new. But so therefore, follow of S is nothing but C comma dollar, because dollar is also in the follow of the start symbol. So there is no intersection here. Right? Is it okay? Right? And AB de Villiers says B for BR. Okay. Let's see. And then from A also, A goes to C comma epsilon. A goes to C comma epsilon. Now this will go into the C column, and epsilon, because of epsilon we will require the follow of which is nothing but follow of S. Now follow of A is this, but this is follow of S. Now follow of A is nothing but follow of S, which is nothing but C comma dollar. Now there is an intersection, C and this C. Therefore there will be a conflict in the parsing table. So therefore G1 cannot be the answer. So Adish also says the grammar is ambiguous. Yes, Adish, as I told, if the grammar is ambiguous, you are also going to get a conflict in the parsing table. You can also solve it using the ambiguity also. Otherwise, you can make the parsing table and answer it like this. Is it okay, guys? G1 is not going to be LL1 grammar because of the conflict. Because this entry epsilon will also come under C column. There will be a conflict in the table. Therefore, this is not going to be LL1 grammar. Right? Now, okay guys, right? So let us solve the other grammar that is given to us. Now this is a single entry, there cannot be any conflict, this is okay. Now here we can have a conflict. Now A goes to C will come under C column. Now A goes to epsilon will come under the follow of A. Now what is follow of A? Follow of A is nothing but first of B. First of B is nothing but D and comma epsilon. Because of epsilon you will also get B. So follow of A is nothing but D comma B. Now follow of A is nothing but D comma B. Now D comma B has no intersection with C, therefore it will not have any conflict. Right? Now let us see this part. B goes to D comma epsilon. Now this will come under the D column. This will come under the D column. Now goes to epsilon, where does it comes? B goes to epsilon. B goes to epsilon will come in the follow of B. What is follow of B? Follow of B is nothing but B. Of B is nothing. Of D and B is phi. Therefore, there is no conflict and the grammar is going to be an LL1 grammar. So the answer is B, that is only G2. So the answer is B, which is only G2. Okay. So the answer is B, which is only G2. Right? So I hope all of you understood the solution. Right? So now let's move to the next question. Yeah, is the solution clear now? Yes, good. So now let us move further. Consider the following LL1 grammar, and this question is regarding the parsing table. And again, this is again on LL1 grammar. So you guys have some 2 minutes to solve this. Please go ahead. And since you have already solved question number 1, you should be able to solve it much earlier. So, by the way, who is AB de Villiers? Maybe can you tell your true name so that I get to know if you have studied from me earlier? I'm sure AB de Villiers have not studied from me. Okay. Yes, it's an MSQ based question. Yeah. Abhilash, you are incorrect. So De Villiers is also incorrect. Please, guys, just check once. So, mind you, this is an LL1 grammar. I'm talking about the LL1 parser. What about others? Kundan also says ACD. Kundan has come down to AC. Just 10 more seconds for getting the final answer. So, what is the answer that we have got? Hemashi says AC, Mansa says AB, Abhilash says ARC. What is ARC, sir? Abhilash? R is not an option. Star AC, okay. AC, okay, good. Kundan says syntax error, D is syntax error. And Anand says AC, Mansa also says AC. Yes, all of you are correct. Answer is AC only. Answer is AC. Let's see. Now, it says that in the LL1 parsing table is stored as 2D array. I'm not making the entire parsing table, or should I make it? Because I have another question also which is following this. Okay, let's make the parsing table fully, and then we will understand that what are the contents. So I will need this grammar. I'll take a screenshot. I'll need this grammar. Okay, so now we know how to make one parsing table. Basically, we have all the non-terminals at the rows, and at the columns we are having the terminals, that is A, B, C, D, and dollar I can see. Is there any other non-terminal which I missed, or terminal which I missed? Is it okay, guys? Right. So let us make the parsing table. Okay, so now if we see the first production, S goes to A, B, B, this will come in the first of this part, that is first of this entire thing is nothing but A. So this production goes in, S goes to A, B, B. Now is A goes to C row, C column, and A row, this will come in B row and D. So let me place this. A goes to C here and B goes to D here. Now what about A goes to epsilon and B goes to epsilon? A goes to epsilon and B goes to epsilon will come in the follow of A and B respectively. Now follow of A is nothing but first of B is nothing but D comma epsilon. Epsilon is not there in the follow, it goes to B. So the follow of A is going to be, D comma B. Now this will come under D comma B. So therefore we place this under D comma B, A comma epsilon A goes to epsilon comes here and it also comes over here. This is one thing. Now B goes to epsilon. This production is left, or this production, I hope you know, this will go into the follow of B. Follow of B is nothing but B itself, the small b. Now this will go into B goes to epsilon. This is the entire table. Rest all other states are nothing but error states. Rest all of the states are nothing but syntax error states. Right? So now you can see the options. S comma A is A, S, A, B, B. Yes, it is. It is. Option A is correct. Option A is correct. AC is A goes to epsilon. I don't think so. AC goes to AC is not. So what is given? A comma C is A goes to epsilon. A comma C is nothing but A goes to C. It's incorrect. It is incorrect. Now B comma B is B comma epsilon. B comma B is B comma epsilon, correct. And S goes S comma dollar is except. This is an error state. So the answer to this question is AC. I hope all of you understand the solution. So Kundan says, which is except state? Kundan, it is a top-down parser. So the except state when will come when you have dollar on the top of the stack and dollar on the input string also. It's a top-down parser. Dollar is needed for its acceptance. Right, Kundan, you understand the part? If you do not understand, the next question will make you understand this, right? Just wait for the next question. So next question, as per the ritual which we are following, the next question will be based on the configuration of the given string. Let's see which is the question, and let's see if we can solve it in the given time frame. Yeah. So everybody is clear with the solution. Can you guys confirm? Abhilash, Kundan, and then we have who else was there? Mansa was there, Hemashri was there, Anant. Can you guys confirm everything fine? Yes, good Abhilash. So, Kundan says clear. Okay. Anant also is clear. Right, good guys. So Kundan's crystal has gone. Is it crystal clear now? It's only clear now. So I hope Kundan crystal has not gone. So let's see the next question. This is again an MSQ based question, and this is based on the LL1 grammar, and this is again a configuration question. So I'll again give you 2 minutes to solve this. Okay, Kundan, your crystal has come back. Good. So the answer is, it's a multiple select question. So AB, you need to check your answer again. only have two answers till now. Kundan, you are correct right now. AB, you are wrong. What about others? Last 30 seconds, guys. Abhilash, Mansa, Anant, what are your answers? Okay. So now let's discuss the solution. I think enough of the time has been given. I hope, I think two of you could answer correctly. Abhilash and Kundan, both of you are perfectly correct. The answer is ACD. This is wrong. So the answer is ACD. Yes. So let us try to see the solution. Just a second. Yeah. So no, you are incorrect. Shilpa, answer is ACD. Yes. So now let's try to see the solution. So right now for solving this question, we'll need the help of the parsing table so that we can see the configuration. So we'll bring back the parsing table for us. So on the activity, I have, as many of you have answered correctly. Now let us bring back the table here, which we drew earlier. That will help us to solve this question. We'll require this table to solve this. So we'll require this table. We'll refer to it as and when needed, right? So here is the question given to you that ACDB has to be derived. ACDB has to be derived, and if we see the parsing tree, it will look something like this. S goes to AABB, and this A will go to epsilon, A will go to C, and B will go to D. So this is roughly which the top-down parser will do, something like this, right? This is something which will be done by the parser, right? Yeah. Yeah, thanks, Pratik. Yeah. So let's see ACDB. How do we derive this? Now this is our string that we want to derive. This will be stored with the dollar. And now the parser, as I said, it is an LL1 parser. It will have a dollar on the top of the stack. We will put S. Now from S we will reach ACDB, that is given in the question, and we have been asked that what are the basic configurations which are reachable and which are not reachable. Let's see. Now from S you are reading A. So at the top of the stack you have S, and over here you have an A. What will you do? You will go to the table, you will consult the table on S comma A. What do you find? You find that you have this production, that is AABB, that is to be used. You will push that production on the top of the stack. So you will push that production on the top of the stack and you will pop out S. So the new stack will be $B B A and A. This is the current stack configuration, and your input pointer does not move. Input pointer only moves when there is a matching. Is it okay till this point? The input pointer will only move when there is a matching, right? So, so currently we have this configuration, and the question, let's see whether it matches with any of the options given in the question. So yeah, so $BBAA, we have derived this. This is reachable configuration, and this is the stack has been put in the reverse order. This option is incorrect. So option A is correct. BBAA, we have BBAA in the stack, right? Is it okay, guys? BBAA is there in the stack. Now let's see. Let's see. Right now we have A on the top of the stack and A also over here. So now what will happen? A will match with an A. A will match with an A, and the stack pointer will come down. Stack pointer will come down, and the new configuration will be this. So the new configuration will be this, right? So the new configuration will be this. So now let us see the option BBA, whether it has been given or not. So we have BBA in the stack also. So this option is also correct. Is it okay, guys? Can we tell this as handle which is on the top of the stack? Yes, it's so handle is something which can be reduced, right? So saying it as a handle might not be correct, because handle is something which is reduced, and we talk about handles when we talk about the LR parsers. This is an LL1 parser, right? You got my point, AB? So it's not like that, right? Handles are when you are going bottom up, there you require handles. So this is top down, right? So now next is, you have A on the top of the stack and you have a C which is required. So you go here, you find an AC, you have to go from A to C. You replace A with a C. So you replace A with a C. So now the new configuration becomes, AC, and the pointer remains at the same place. So if you go back, let's see whether we have any option of this type. Yes, this option is here, BBC, that is also there. So option A, C, D, all are correct. For the sake of completion, let me complete the parsing so that there are no doubts in future. Now C will match with a C. Now we have already solved the question. We are just completing for the sake of clarity. Now C has matched with another C. So therefore, you can simply move the input pointer. You can simply move the input pointer like this, and the input pointer will go. Sorry. Undo. Where is undo? Undo doesn't work. Okay. Anyways, I'll write it again. This is A, C, D, B. Correct? Now let's see. Now here we stand over here, here we stand over here. Now on BD we have this expansion. So what we will do is we'll replace it with a D, and the pointer remains the same. Now D will match with the D. The input pointer will move down, will reach here. This is gone, and this is also gone. This is also gone, right? Now B will match with a B. This is also gone, and the pointer will move over here. Now dollar matches with dollar. We are finally going to accept it. Although this much is not needed for solving the question, you could have stopped earlier also, right? Is it okay, guys? Are you able to solve such type of questions? If such type of questions are asked in the exam, I hope all of you will be able to attempt them properly, right? So this was all about two parsers we have covered. Operator precedence parser we have covered, LL1 parser we have covered. Now let us move towards LR0 and SLR1 parser and see how much we can complete. But in general, We will continue till 9:15 and we'll see, we'll try to cover more and more questions on LR0 and SLR1 parser, and similar questions can also be asked on CLR1 parser and LALR1 parser also, right? So I just wanted to give you the brief hint to give you the big picture that where and how the questions can be asked from the parsers, right? Let's see the next question. Okay, so let's see the next question. Okay, so this is again an MSQ based question, and I'll again set the timer to 2 minutes. Kundan, you are incorrect. Kindly recheck your solution. So Anant, you are incorrect. Hemashri, you are perfectly correct. Kundan, you are also incorrect. Just cross check your answer, guys. Last 30 seconds at I'll discuss the solution. Okay. So I hope many of you are able to find out the answer. Mansa, you are also perfectly correct. Anant, you are wrong. Kundan, you are also right. So the answer is B, C, D. Let us see the solution now. Answer is B, C, D. Let's see the solution. So the grammar given is E goes to E plus T, T and T goes to I. It has been asked that whether the grammar is, let's see from the bottom, G1 is an operator grammar. Yes, it is, because there are no null productions and there are no two terminals together. Everything is fine. D has to be the answer. Right, guys? D has to be the answer. Is it okay? Right? All good till this operator grammar? This is a combination of various parsers. This question is a combination of various parsers. I hope you are able to understand this. Right? Okay. So now G1 is LL1. So how to solve for LL1? We'll just check. So T, in the row of T, there cannot be any conflict. Right? There can be a conflict in the row of E goes to E plus T slash T. Let's see whether there is a conflict or not. Now the first of this entry will go in the first of T, E plus T. The first of E plus T is nothing but the first of E. And okay, before going for that, you can simply see it also like this also, that this is a left recursive grammar. And left recursive grammars are never LL1. You do not even need to check first, follow, and nothing else needs to be done. You can simply solve it. We can simply solve it using the idea that LL1 grammars do not allow left recursion, right? So you can save your time over here. So A is not the answer therefore, and for LR0 and SLR1, as somebody pointed, that we have to draw the DFA. Okay, we should not call it a DFA, it's a DFA of the canonical. Basically it is called canonical collection, right? So it's like canonical collection in which we take the closure of the LR0 items, right? Let's see how do we make the canonical collection. So for that I'll need the grammar. I'll remember it. E goes to E plus T, T and T goes to I. Let's see how do we draw this. So E goes to E plus T slash T and T goes to I are the only productions that I have, right? LR0 items, Kundan. Canonical collection of LR0 items, this is what we call it. So E goes to E plus T, T and T goes to I, this is what I have. Now let us see. So the first thing that you have to do is you are going to add a augmented production in this. So for example, let me take it as S. S goes to E is my first augmented production, and in the state number 1, I will add S goes to dot E. Now E can go to E plus T and E can also go to T and T can go to I. So this is my state number I0. Is it okay, guys? Right? Now, if we get an E, or we might get a T, or we might get an I. So if we get an I, we will go to T goes to I dot. If we get a T, we goes to E goes to T dot, and if we get an E, we will go to S goes to E dot, E goes to E dot plus T. This is how it will look like. Right till this point? Okay, everyone? Yeah? Is it okay, guys? Right? Okay. So now let's move ahead. This cannot be further expanded. This cannot be nothing can be done. But from here, we might get a plus, and a plus will give us E goes to E plus dot T, and T can be further expanded to dot I. Okay, guys? T can be further expanded to dot I. And now, if I get an I on this production, I will go to this place, T goes to I dot. And if I get a T, I'll get E goes to E plus T dot. This is how it will look like. E goes to E plus T dot. Is it okay, guys? You can just look at the canonical collection. Just let me know if it is clear to you or not. I'll just pause for 1 second, pause for 2-3 seconds just to give you time to check whether it is okay or not. Okay, guys, till this point, everyone okay, right? Yeah. So once we have this, let me name the states as I0, I1, I2, I3, I4 and I5. Right? There are some 6 states right now. And we have to check whether there is a conflict in the table or not. If there is a conflict, then we can say that the grammar is not LL1, LR0. If there is no conflict, then we can say that the grammar is LR0. For getting a conflict, we will either require a shift reduce conflict or a reduce reduce conflict. A shift conflict cannot happen, right? So let's see over here. All the steps are shift steps. Over here there is one reduction also happening. Here there is one reduction, and over here this is one shift. But this reduction is basically of the augmented production. Therefore, this will only come under dollar. This will only come under dollar. This will go under plus. There is no conflict. Here there is only reduction, only one reduction, only one reduction. Over here no reductions. Over here only one reduction. So there cannot be any conflict. So this is LR0 also, and this is also going to be SLR1 also, because this entry again is going to be coming under dollar only. It is going to be coming under dollar only because this is the reduction of the augmented production, which only goes under dollar, wherein we will write I1 comma dollar is equals to accept. Right? Everyone okay with this point? So therefore we can simply say that this grammar is both LR0 as well as SLR1. So therefore the answer to this question is B, C and D. Therefore the answer to this question is B, C and D. Right? Is it okay, guys? Okay? All good? So now let's move to the next question. Here is the question for you guys, and I'll give you some 2 minutes to solve this. Yes, Abhilash, thank you. Yeah. Yes, do we have any answers? Hemashri, your answer is incorrect. Rajan, you are correct, and Kundan, you are also correct. What about Abhilash and other guys? Kindly let me know your answers. Yes, guys, the answer is no, it's CD only, not BCD. The answer is CD only. Let's see the solution. Answer is CD. Who answered it correctly? Anant answered it correctly, and Mansa answered it correctly. Very good, guys. And Rajan, in case of LR0 at state L2, there is an inadequate state. What do you mean by an inadequate state? Rajan, can you please elaborate? In previous question, it is not LR0. Why it is not LR0, Kundan? SR, I'm not very clear. Just a second. What you are saying? So maybe you write the question clearly. I'll be able to answer it that way. But let me first solve this question. Okay. So it says G1 is an operator grammar. Yes, guys. Again, it is an operator grammar. The non-terminals have an operator in between, and there is no null production. So operator grammar is true. Answer. This is the correct one. So D should be a part of the answer. And LR0 and SLR1, we again have to make the canonical closure of the LRD, canonical collection of the LR0 items. From there, we'll get to know, right? So, inadequate means SR. Inadequative means SR. I have no idea what you are trying to say, Rajan. What do you mean by inadequate? I'm listening this term for the first time. Okay, conflict you are saying. Yes, there is going to be an SR conflict in one of the states. Let's see whether we have it or not. Let's see. Yeah, okay. So now G1 is LL1. Now again, okay, I'll solve LR0 and SLR1 together. Let us see whether G1 is LL1 or not. Again, we can see that although the recursion has been made as right recursion, now there is no problem. But now there is a problem of left factoring. E goes to T plus E also and T also. The factor T is common. The factor T is common. Therefore, this is not LL1. So now for B and C, we'll have to make the canonical collection of the LR0 items. From there, we'll get to know whether it is correct or not. Let us see. Let us see. So again, I'll have to make the canonical closure. Let's see. E goes to T plus E T. E goes to T plus E T. And E goes to T goes to I. I may be an ID or something like that. E goes to T plus E T and T goes to I. So now over here, you can clearly see we will start again with the first one as S goes to dot E, that is your augmented production. That is your augmented production. S dash goes to dot E. Now E will go to dot T plus E and E will also go to dot T and T will go to dot I. So this is your first I naught, first state, which is I naught. Now over here on E, you will go to S goes to E dot. This is your I1. Or here on T, you will go to E goes to T plus T dot plus E, and you will also goes to E goes to T dot, which is where the problem will come for the LR0 parser. We'll discuss it. I2, and then let us say we have T goes to I dot. Just a second. T goes to, just a second, T goes to I dot. Right? Clear till this point? Right. So now when we get a plus, we go to, just a second. When we get a plus, we go to E goes to T plus dot E, and E needs to be further expanded to E goes to dot plus T plus E, dot T plus E, and E also goes to dot T. So this is your another state, which is, say, I have not numbered from here, I3, and let's say this is my I4, right? Okay till this point, right? So now over here, nothing can be done over here, nothing can be done over here. Let's see this. Over here, if you get an E, you get over here, if you get an E, you get, just a second guys, over here if you get an E, you get E goes to T plus E dot. This is one thing that you get, E goes to T plus E dot. And now over here, if you get a T, you will end up coming back to this state, because T dot plus E, and then you will get E goes to T dot also. So this will be something of this type. So over here you will get a T. So this is basically the canonical collection of the LR0 items for this parser, for LR0, for SLR0 and SLR1 and LR0 parser, right? Okay till this point, yeah. Okay, so now over here we have to again check whether there is a conflict or not. Then the conflicts, as we discussed just before in the previous question also, the conflicts can be of the two types. Either it is a shift reduce conflict or a reduce reduce conflict. We cannot have a shift conflict, because it is the canonical collections have been made in such a way, right? So now over here no reduction is happening, so this state is okay, this state is perfectly okay. In this state only one reduction is happening, it's perfectly fine. But over here there is a reduce action also, and there is a shift action on plus. So there the SR parser, SR0 parser will have a, sorry, LR0 parser will have a conflict. LR0 parser will have a conflict over here. LR0 parser will have a conflict over here. But SLR1 will not have a conflict. Why? Because SLR1 will put the values in the follow of E. So this will put the value, this production E goes to T plus, the reduction of this production in all the cells. Now this guy will only put this reduction only in the follow of E, and let us calculate the follow of E. We know that the follow of E is nothing but the follow of E itself, which is nothing but dollar. So this entry will go in the dollar column, and this entry will go into the plus column. So there is no conflict. Therefore, this parser is not LR0 but SLR1. So the answer to this question is, C and D. So C and D are the correct answer, and I hope all of you understood the solution. Right guys? Right? So I hope you understand the solution, and this is how the questions can be modified on different parsers, and they can ask you the questions regarding whether the grammar is of the particular type or not, right? Whether the grammar is of the particular type or not. And similarly they can ask you they can ask you questions regarding the configuration of the various parsing tables, and also they can have questions also on as I said, on the configuration of the parsing, and also the parsing table also. They can ask you questions on that. Is SLR not getting? Yes, it is SLR, right? I said SLR is correct, right? SLR1 is correct. Yeah, because this reduction will only come under the dollar column, and this will come under the plus column. So therefore this is perfectly fine with SLR1. This is not fine with LR0, because LR0 is going to place this reduction under all the columns, and it will coincide with the shift step of the first production, right? The production above it, right? I hope, Rajan, it is clear, right? So now this is about how the questions can come over on LR0 and SLR1 parsers, and yeah. And for the sake of time, what I will do is I'll show you how the questions can be asked and how you are going to solve the questions further, right? So what I'll do is I'll show you how the variations in the questions can be, and then in the meantime you can take a you can look back at this video and you can look at the solutions of the questions also, right? So let me take you through the questions which I have in my store now, and you can solve these questions in your free time, and then if there are any doubts you can post on the comments. I'll reply it over there. Okay? Yeah, can you send all questions and solution? Yes, Anant, I'll give it on the I'll give it on the Telegram group. Don't worry about it, right? And moreover, now let me take you through the questions, that just to show you that how the variations can come up, because the agenda, as I said, for this session is to show you how the variations can come in the questions and what are the most probabilistic questions. So in the interest of time, let me take you through the questions which are there, right? Let's see. So now one of the variations can be, again, now this question is an MSQ based question which says that consider the following LR0 grammar, and it says that again it is about the parsing table. So again the questions can come on the LR0 parsing table also, and this is one of the questions, right? So you have the video will be available online. Whenever you are free, you can solve this question and find out the answer to this question, and the answer comes out to be, so what you are going to do, you are going to make the canonical collection of the LR0 items, and from these LR0 items you are going to make the canonical collection, and from these LR0 items what you are going to do is you are going to make the parsing table and check whether these things are correct or not, right? So this is how one of the variations can be on the LR0 parser, and the answer will come out to be B and C. You solve this question. If there are any doubts, post in the comment. I'll be there to answer if there is any issue, right? So now another variation can be SLR1 grammar. So let me, if I have given you an SLR1 grammar, and we just saw that this grammar is an SLR1 grammar, again the question can come on the parsing table, and these are the contents of the parsing table. What again you have to do, you have to again make the canonical collection of the LR0 items and then make the parsing table. Are you getting my point? So this is how again the variation can happen in the question, and maybe I'll just pause for 3 seconds, 1, 2 and 3, so that you can look at the question, and the answer will be B and D. So again you solve this question, and if there are any doubts, I will always be there to solve it on the comments, right? And yeah, correct. So this is another variation. So this was regarding the parsing table. Now the last variation can be in the configuration. Let's see the questions on configurations, how they would be. So again over here more information needs to be given because the states also comes in the parsing table. So this question is about the LR0 grammar, and over here we have the grammar also with us, right? So now this question is about asking you what are the possible stack configurations during the derivation of the string I plus I, and you have to tell which of them are possible. This is again an MSQ based question. I am again pausing for 3 seconds so that you guys can look at the question in detail. On the count of 3 I'll change the slide. 1, 2 and 3, right? So for this the answer will be ABCD. All of the configurations will be reachable. Again you guys solve it and just get back to me if there are any doubts, right? Okay. So right, so what you are going to do is you are going to do the LR parsing. Since you already have the LR0 parsing table from the previous question, you are going to apply the parsing algorithm and tell me whether these configurations are reachable or not, right? Okay. Yeah Rajan, no issues. Thank you, you're welcome. And now for similar question I have repeated for SLR1 grammar, and I have changed the grammar to be an SLR1 grammar, and over here again the question is possible stack configuration or configurations which are reachable, right? So similar variation can be done in SLR1 parser also, and you may solve this at your leisure. I am again taking on the count of 3, I'll change the slide so that you guys can have a view of the question. So I'll count 1, 2 and 3, right? So this is how the variation can come in SLR1 parser also. And again, the answer will be ABCD. Do solve it and let me know if you got the correct answers, right? Now, next is the question on CLR1 and LLR1 parser. CLR1 and LLR1 parser. So this checks whether you know CLR1 concepts or not, or LLR1 concepts or not, right? So over here again, what you are going to do, you are going to make the canonical collection of LR1 items now. And you will check whether there is a conflict or not, and based on that you are going to answer this question. So again, so this is the question again, the first variety of the question, which is asking whether the grammar is of the particular type or not, right? Perfectly fine. Yeah, right. So again, on the count of 3 I'll change the slide so that you can solve the question in the meantime whenever you are free. So 1, 2 and 3. Yeah, and the answer to this question will be C. You guys solve it and just let me know if there are any issues, right? So this is how the variation can come over the LLR1 and CLR1 parsers. And of course, there can be questions on configuration also. There can be questions on whether the stack is reachable, whether that stack configuration is reachable or not, or whether that parsing table, the contents of the parsing table, they'll ask you whether this is the which of the following are the possible entries in the parsing table, right? The similar way, the way we did the earlier questions, right? So similar things. Yes, Rajan, I'll do that. Not an issue. I already told that I'll do that, right? Okay. Yeah, Abhilash, I'll get back to your question. Let me complete this point. And the last thing that we have is, this is the last question for the day. And the question is about, again, the similar thing, that is CLR1 and LLR1, and or both of them or none of them. Again, you can solve this question based on the canonical collection of LR1 items, right? So this is also the way you will solve this question also. And on the count of 3, I'll change the slide so that you can take a snapshot and solve it. I'll count 3, 1, 2 and 3. Yeah. So now answer to this question will be A, and you just try it whenever you are free, right? And with this we move to the last question. Again, as I said, the parsing table and the configuration questions can come up. Now one more variation is, it might ask you, consider the below LLR1 grammar and how many reduced sections are taken by the LLR1 parser during the derivation of the string AB. So this is again an NAT based question. This is an NAT based question. You have to tell me how many reductions are being done. So again, in this question, let me solve it in a minute. This is a very, very simple question. People might end up solving this entire, people might end up in making the parsing table, then first the canonical collection and then the parsing table, and then might end up applying the parsing algorithm, which I think is really not needed for solving this question, right? Abhilash, I'll get back to your question at the end. Just wait for a while. But just look at the question, guys. Once it says that this is the LLR1 grammar, and it asks you that how many reduced sections are needed. So you might end up solving this question from the scratch. You might end up making the canonical collections. You might end up making the canonical collections, and then you are going to make the parsing table. And as I said, you will finally do the LLR1 parsing. That will take a lot of time, and that might cross the assigned 3 minutes, the average 3 minutes in the GATE exam for a question, right? So now how you can do it simply, you simply draw the parse tree. It is just asking you the reduced sections. Now the parse tree will be something like S goes to AA, AB, and then A will go to, sorry. So this A will go to $, epsilon. This A will also go to epsilon, and then you will be able to derive AB. So if you ask me how many reduced steps are needed, you will only require 3 reduced steps. One is this reduction, other is this reduction, and third is this one. So at the end of the day, not more than 3 reductions can happen, and that's as simple as that. You can simply solve it using the knowledge of the parsing table. You do not need the complete LLR1 grammar to solve this question, right? So I hope if such kind of questions come, you will be able to solve it with smaller tricks, right? So yeah. So with this, I think this is all about The answer will be 3 for this question. And with this, this is all about the variations in the questions. Although we could not cover in detail the LR1 parser, SLR1 parser, or the CLR1 parser, or the LLR1 parser, but the similar questions will come up, and I hope with the theory that we have already given you, you will be able to solve those questions. Also, I have discussed the variations in the questions in detail, right? Now, Abhilash, I'll come back to your question. You say, sir, there is any short trick to check for LR0, SLR1, or we have to draw all canonical items, same for CLR1 and LLR1. So again, Abhilash, you are correct. You will have to draw the canonical items. There is no other way. And in general, this might take more than 3 minutes also. So therefore, I always suggest to the students to solve such questions in pass 1, in pass 2, wherein you will the questions which might require more than 3 minutes to solve, right? So there is no shortcut to do that, but yeah, one shortcut is as soon as you get the conflict, you stop. There is no point in making the entire thing. That's the only shortcut that is available. There is no other shortcut which is available for solving such questions. Does that answer your question, Abhilash? So the only shortcut is as soon as you get the conflict, you have to stop. But if there is no conflict, you will have to go till the end and then check whether there is a conflict or not, right? Yeah. So this completes this session. I hope I could show you the variations in the questions, although we could not solve all the questions. But I hope whenever you have time, you will go back to this to the video and you will be able to solve all the questions. If there are any doubts, I will always be there to answer on the comments. And the PDF will share on the Telegram group. Don't worry about the PDF, right? So guys, this is all about today's session, and let me declare the next session. Next session will be taken by Vijay Agarwal sir. That will happen tomorrow. Vijay Agarwal sir will take the session on operating systems tomorrow and day after tomorrow. That is, tomorrow is 30th and 1st of today's 29th. Yes. So 30th of November and 1st of December we'll have sessions on operating systems. Okay. So next question is when you guys are going to see me back. I'll be coming live again on so I'll be coming live on 19th of December with a session on programming and data structures. Programming and data structures. I'll be coming live again on 19th of December. Tomorrow and day after tomorrow, you'll have sessions with Vijay Agarwal sir, and the sessions will be on OS from on 30th and 1st of December, and the timings for all the sessions are the common, that is 6 p.m. to 9 p.m. right? So see you all again in the sessions. Yeah, so keep working hard, and of course now you have a defined target. The exam is on the first Saturday of February, and you have limited time. Somebody asked that how to discuss the techniques, how to study and all. For the IMS students, we do have mentorship sessions. We have my plan sessions. You can come up in these my plan sessions and discuss your detailed strategy. Although, and sometimes we also have one-to-many sessions also. In there also we discuss these strategies. But this session was particularly to discuss the most frequently asked questions in compiler design. So that's not the agenda for today's discussion. But yes, we'll have some one-to-many sessions in which you can ask, and IMS students can also book my plan sessions too, right? And Rajan says tomorrow I also have TOC online class. No, tomorrow it will be OS. As I said, tomorrow will be OS. Acha, tomorrow also have TOC online class. Okay, that HomeGate class are you talking about, Rajan? So yeah, so HomeGate I'm going to teach TOC from tomorrow. We'll start TOC tomorrow. We'll have 14 4-hour sessions. We'll cover TOC there, right? Rajan, did I understood correctly? Yes, Rajan. I'll see you tomorrow in the online class from HomeGate class. From it will start from tomorrow and it will continue till, I hope, I guess till 23rd of December. 14 sessions will be there, right? Yeah. So I hope everything is fine. So guys, I hope all of you got a glimpse of all the questions that can be asked in GATE, right? So yeah. So is there anything else which anybody wants to ask, or should we close the session? Yeah. Abhilash, Rajan, Kundan. So what is the status, guys? Everything okay? Should we close the session? Yeah. Yeah. Bye, Rajan. Yeah. Bye. Yeah. Yeah. Thank you so much, guys. See you again on 19th of December with a session on programming and data structures. See you. Yeah. Good night, Abhilash. Yeah.